B is 1, A is 2, B is 2, so log n to the power log A to the base B becomes n. And my Fn is order 1. Because my Fn is order 1, therefore, because my Fn is order 1, therefore it satisfies case 1 and the algorithm becomes n log B to the base. We will see some classical, we have seen many cases of case 2. We will see few classical examples of case 1. So the first problem we try to solve is the multiplication of two n-bit numbers. Suppose I had two n-bit numbers, 101001, 101010, and I want to multiply them. The result of two n-bit number multiplication can be at most how much? How many bits?
2n.
2n bits. It can be 2n bits. And by the longhand multiplication and addition, you can see that this algorithm, by basic longhand algorithm, will be order n squared. So let us try a divide and conquer. Is everybody clear that this basic problem by longhand multiplication will end up me doing order n squared computations, at least n squared computations? Because for every row, I have to do order n. And I have to do so many rows. So I will be ending up doing n squared. Is it clear to everybody? Yes? No?
Yes, sir.
Yes, sir.
Now let us break it up into two parts. So if I break it up into two parts, x1, x2, y1, y2, then x1 can be written as this. X can be written as x1, the x1 part portion, into 2 to the power n by 2, which is actually padding it up with n by 2 zeros, and x2. So padding with zeros is just a shift, left shift. So in n-bit numbers, multiplying by 2 is a left shift and dividing by 2 is a. If I left shift the number, I multiply by 2. If I want to divide the number by 2, what do I have to do?
Right shift.
Right shift.
Right.
So these are my two numbers. And x into y can be written in terms of these x1, y1, x2, y2 as 2 to the power n x1, y1 plus 2 to the power n by 2 x1, y2 plus x2, y1 plus x2, y2, which ends up in 1, 2, 3, 4 multiplications of size n by 2. And the addition, obviously each addition is order n time. Each addition of numbers of size n by 2 to yield a number of size n, or a number, and these shifts are also, one shift is only 1 unit of time. So these shifts and adds, this is for shift and add, is order n time. So now my equation has become this. So let's write this equation cleanly. Tn is equal to 4 Tn by 2 plus order n. What is n to the power log a to the base b here? What is a?
4.
4, sir.
B?
2.
2.
So log a to the power is n squared.
N square.
And because this is n squared and this is order n, it falls under which case of master theorem? Case 1.
Yes, sir.
Since it falls under case 1 of master theorem, I end up in an order n squared. So all this divide and conquer circus did not help me. I know that I can do the recomposition in order n time. But I do not know what else to do. Now if I go back to my equation, is there any point in reducing this order n to order 1? Will it make any difference to this equation's complexity?
No, sir.
No. So what must I reduce? I must try to reduce this. So if I have to always break it up into two parts, my place of reduction is this, which means that can I do some jugglery of computation by which I can reduce the 4 multiplications of size n by 2. Up to here, is it clear to everybody? Anybody having a doubt, ask. I'm not going to ask anybody anymore because I've realized that it is fruitless job for me to go on asking people. So those who don't respond, I will assume they have understood. And we will only give teachers assessment marks for people who respond, whether saying yes, no, understood, not understood, only then we will do. So is it clear up to here?
Yes, sir.
Yes, sir.
Yes, sir. Yes, sir.
So now here is the trick. Somebody had a doubt? So here is the trick. I have to do a x1 y2 plus x2 y1. This is what is my job. I have to multiply x1 y2 and x2 y1. So I create a new value. A is equal to x1 y2 plus x2 y1. This requires how many multiplications? 2 multiplications. Sorry, let me use some other color. This requires 2 multiplications. Of size n by 2. Then I rewrite this one. I rewrite what I want to do as x1 x2 x1 plus x2 into y1 plus y2 minus x1 x2 minus x2 y2. If I rewrite this, if you open this up, you see that you will get this. X1 y1 I will get here. X2 y1 I will get x1 y2 2x1 y2 and x2 y1. By combining all of this together, I see that I require, instead of doing 4 different multiplications, I do 1 multiplication here, 1 multiplication here, and 1 multiplication of these two sums. And if I do this, I will still get back whatever my results are. My results will be 2 to the power n x1 y1 plus 2 to the power n by 2a plus x2 y2. This a. This a, which was x1 y2 plus x2 y1, I have now rewritten in this form. By rewriting in this form, these two multiplications are avoided and replaced by a single multiplication here, one multiplication here, and one multiplication here. And in my final result, x1 y1 is required, which is already there here. x2 y2 is required, which is already there when I computed a separately. So I have stored this in, say, z1, I've stored this in z2, and I've stored this result in z3. And this complete thing, which is equivalent to x1 y2 plus x2 y1, is a. I've computed that using 3 multiplications. One multiplication with this composite x1 plus x2 into y1 plus y2, another multiplication x1 y1, another multiplication x2 y2. I have avoided multiplying x1 y2 and x2 y1 directly. And when I compute this x1 y1 I get from z1, which is already pre-computed when I computed a. I know a, and I know this is z2. With this, by using this intermediate a, which is done, which is x1 y2 into plus x2 y1 done in a different way, I have saved one multiplication. Who has not understood this part? So by saving this one multiplication, my equation, which was 4tn by 2, now becomes 3tn by 2. And this order n remains the same. And therefore, this complexity now becomes this. And therefore, my multiplication of two n-bit numbers complexity reduces from order n squared to order 1.59, which is log 3 to the base 2. Any questions here? Any questions?
No, sir.
Good, good. This whole method is replicated, reused in matrix multiplication. This is the famous Strasson's algorithm for matrix multiplication. Here again, I have two matrices, n by n matrices, A and B. One is broken up into 4 n by 2 submatrices, A, B, C, D. The other is broken up into 4 n by 2 submatrices, E, F, G, H. And if you do matrix multiplication, you have to do AE plus BG for this portion, AF plus BH for this portion, CE plus DG for this portion, CF plus DH for this portion. And that ends up in 8tn by 2 plus order n squared, n log 8 to the base 2 is equal to 3. Sorry, log 8 to the base 2 is equal to 3. Log 8 to the base 2 is equal to 3. Therefore, this algorithm becomes n cubed. The only place again I cannot reduce matrix addition below order n squared because I have to see n squared elements. I just cannot reduce it. So my option is to reduce this. Here again, I now again use arithmetic jugglery and I compute P1, P2, P3, P4, P5, P6 and P7. Then there are other ways to do it, which require only 7 multiplications. So I have taken just 7 products which involve 7 multiplications. The rest are all addition and subtraction, which is all order n time. And my recomposed value is a combination of these numbers by addition. You can check it out. Once you check it out, you will see that now that 8 now becomes 7. 8 is cancelled to 7, and now 7 is log 7 to the base 2, which is 2.81. And by this new divide and conquer technique, I have reduced the complexity of matrix multiplication to the n to the power 2.81. So this gives you another flavor of optimal splitting in such a way that I can use and reuse this dimension to utilize that first rule of master theorem more effectively. With this, we will complete today's class, but there are 2 other problems which I will ask you to read from what I have taught in the pre-recorded videos provided to you. Problem 1 is the closest pair, and problem 2 is the convex hull. It is done in my videos, and I have already shared them with you all. On Thursday, your tutorial will be like this. It will be an assessment. I have now decided that it will be an assessment where I will randomly pick a student and ask them how to solve these problems. We will go through the solutions, but the solutions will be given by the students, and we will evaluate you according to that. So consider this to be a short tutorial test on Thursday, where the closest pair and convex hull problem, which is given in my videos, and those videos please go through by Thursday and come to class. Both these problems are also done by others. It is found in the textbooks. So please go through them and come. And on Thursday, I will start picking up students and asking them. So it will be a test and you will be evaluated. Please remember. Any further questions? Otherwise, we can stop for today. We have done enough.
Sir,
Any? Yes.
sir, while writing program, if we do